Okay, so yesterday we talked about how to apply Hess's law in a two-component type of reaction. Today we have three components. Let's take a look at these three components. I have component A located here, component B, and component C. The first thing I want you to think about is, are there any unique items, substances, that only show up in, say, component A? Or any unique substances that show up only in component B, or only in component C? And then what you're going to do is you're going to compare that to the original equation and see if they are on the same side of the arrow and do they have the same coefficient. If they don't match, then you need to perform a modification to get them to match the equation on top. I'm going to give you some time now. If you're watching this video, now would be a good time to pause and try to identify the unique items and what kind of modifications are necessary. So, I'd like you to do that right now. Find the unique pieces and figure out which mods you need. Okay? Alright, pause the video now and work. Alright, so checking back in, what is one thing that is unique to component A? Is there anything in component A that shows up in the one on top that can only come from component A? Does C come from component A?
No.
No. How about H2? Does that come from? No. What does come from component A? C2, H2. This comes from component A. Do we see C2H2 in component B or C? No, then I would consider this unique to component A. The question then is, are they on the same side of the arrow or are they on different side of the arrow? What does that imply? I need to modify component A to make it look like the one above. I need to apply what? I need to apply a flip. Okay, so I'm going to write here that I want to flip component A. So far so good? Yes. I'd like you to talk with your partner about what mod needs to be applied to component B. Looking at component B, is there anything that is unique that must come from component B and component B alone? What would that be?
C.
C. Okay, so we can see C up top, and we see C from component B. Are they on the same side of the arrow?
Yes.
Yes. So we don't need to apply a flip here. But do they have the same coefficient? No. So the mod that we need to apply here is multiply by 2. So when I do a multiplication by 2, I actually go ahead and just apply it to the equation. I basically double all the coefficients to everything in the whole equation. So instead of 1C here, I'm just going to change it to 2 C's, 2 O2s, and 2 CO2s. Any number that is in front essentially gets doubled. What happens to the delta H then? We multiply the delta H by 2 as well. Which brings us to component C. If I'm looking at component C, what is the unique item in component C? H2. H2 can only come from component C. And up top here, is it on the same side of the arrow?
Yes.
They're both on the left, so we don't need to flip. Do they have the same coefficient?
Yes.
Okay, so what does that tell me that I should do for a mod?
Nothing.
No mod. So at this point, what I'm going to do is I have a flip for A, and I'm going to rewrite A, and I'm going to make a new entry in the bottom. I'm going to call this flip A. And I'm going to take everything on the right side of A, and I'm going to put it on the left, and everything on the left is going to then go on the right. So I'm just going to rewrite it. 2 CO2 gas plus H2O liquid, arrow, C2 H2 gas plus 2 and 1/2 O2 gas. What happens to my delta H at this point? The sign changes now to positive. 1299.5. And I'm going to just cross off the original A so I don't get confused. Bam. What I'm going to do now is I'm going to look for something that shows up on the left side, exactly the same. So H2O liquid is not the same as H2O gas. So it needs to be the same substance with the same state of matter. We're going to look for something on the right side, and if they both are the same, we can actually cancel them out. Kind of like x on the left of an equation and x on the right side of the equation, we can just cancel them out. I'd like you to look for things that can be canceled out. There are 3 things that can be canceled out. Talk with your partner now. Good time to pause the video. Okay, so we can see that there is an O2 located on the left side. One of them says half. If I cross that off, that means I can remove a half on the right side. On the right side, I see 2.5. I can cross off the half here. 2.5 minus half is 2. Are we okay with this? So I see 2 CO2 on the right. And is there a 2 CO2 on the left? Yes. Down in my flip A. So that also cancels out nicely. Is there an H2O liquid on the right? Yes, it's located in C. And is there an H2O liquid on the left? Yes, it is located in flip A. Very good. There is one last thing we can cross off. What is that? The 2O2. The 2O2 is located in component B. And we can see in the flip A, it used to be 2.5, but we already subtracted half from there. And so we can now delete the rest of it, 2O2. How was that? Not bad. What we're going to do now is we're going to combine all of the equations together, B, C, and flip A. We basically will take everything on the left side and add everything together, combine like terms, and then it will output on the left side. So I'm going to call this the total equation. So I'm going to take everything on the left. So that's 2 C's, solid, plus what else? What else? H2 gas is also located on the left side. Is there anything left over on the right side? C2H2 gas. I'm going to get my highlighter now, and let's see what we made. How does that compare to the equation that we were trying to do and get on top? It is exactly the same. This is amazing. This is truly astounding. The question, of course, is what is the total delta H? This is where you need to do some math. Go ahead and try to do this. Pause the video and try to do this on paper by yourself. Okay, let's check in. The delta H total should be the sum of all the different delta H's. So that would be negative 393.5 times 2 plus negative 285.8 plus 1299.5. Notice that the 1299.5 has changed signs, it is positive now. The total here is going to be positive 226.7 kilojoules. So, as far as sig figs go, when we multiply, we should retain the same number of sig figs. A times 2 here is a perfect counted number. It should retain its 4 sig figs. So you should get like 700 something here, right?
I got 787.
Point 4 sig figs, right? There's point something.
It's
Point
just
0.
Yeah.
So over here, I have one place past decimal. When you add things together, you retain the digits after the decimal. The difference here is that you don't have a point 0 when you multiply by 2 because your calculator doesn't show you that point 0, and that is the difference.